This is, I talked about the imaging techniques of that depends on the hemodynamic change. But you can see here that in magnetic type, you can also make a topography of the brain by just checking the electrical change that occurs, but not directly, by a magnetic influence of the change in the electricity of the brain tissue. But maybe this is the most expensive because it is a relatively new technique, and it has the advantages of both the electrical and the hemodynamic type. It will try to make some fast method and high temporal resolution of checking the changes with a high spatial resolution also. And also the deep size of the brain has been shown recently that it can be checked by this technique. The most useful technique for our projects here in engineering is the electroencephalograph, because it is very cheap and portable. But it has its own drawbacks, that the resolution, the spatial resolution of this technique is relatively low. Although that the temporal resolution is high, but there is some signal destruction because of the underlying tissue of the bones and the relatively far away signal sources that there will be some mixing with the nearby fibers. The types of the electrodes that they used for EEG, the previous slide, you can see that this type is every node here, there is some electrode, and they put some conducting gel beside, underside the electrode, so that the hair will not isolate the electrical signal. But there is some trials to make dry electrodes, as you see here. It is a slightly painful type, because there is some pin-like electrodes that can penetrate the hair follicles to reach the scalp, and there is some direct contact with the scalp itself. And there is passive and active electrodes. Passive electrodes is the electrode without an active electronics component. Whereas in the active type, the signal-to-noise ratio is better, and it is much more immune for noise, because the electrical components, they put it on the electrode itself. So the electrode is an active type. And maybe even wirelessly transmitted. You will see that there is some small electrical part that is direct on the scalp, and there is some wireless transmitting of the signal that pick up. And it is much more useful for animals that moving and maybe the wire. And there is the contact and non-contact. Recently there is some proposed method to use laser tiles that transmit the signal of the light on the scalp. And you, when it's reflected, there is some changes in the frequency and the phase, and that will be correlated with the electrical changes underlying the tissue. And this is much more better than all the previous types, because it is much more immune for noise. You will not pick up any noise because it is light. And it is a non-contact, because you should not contact the skin, so there is no hassles of movements of the patient and etc. So it's very, very accurate type of electrodes. The DARPA and the Research Institute for the Military of the US, they used a helmet and put inside the helmet some electrodes that you see here, the red lighted electrode, which is a laser emitting diodes. And just he put it on his head, and without any conductive gels, without contacts, and they can measure the electrical signal, a complete EEG system without noise. And they measure the workload assessment in the flight, so that they can know that the pilot is now concentrating on something. They will not talk to him and not bother him with anything else. Maybe he's in danger. Maybe the better type is the electrocorticography. It is EEG machine, but the electrodes, they put it directly on the brain itself. It is a highly invasive technique, but it is still used in clinical hospitals because some patients need some surgery, so they try to, most commonly used for epilepsy, who need some surgical intervention to remove some parts, so they need an accurate method to visualize where is the part that is mostly affected so that they can remove it. The electrodes, you can see that there is some array of electrodes, and every electrode will be put directly on the brain. Actually, there is some barrier between the electrode and the brain tissue. You can see, I don't think, yes, maybe you can see here in the picture that there is some glimpse on that side, which is the meninges that covering the brain. So it is not directly on the tissue of the brain itself.